PAROL6 is a 6-axis desktop robotic arm designed in 2023. In a very short time, it became one of the most popular DIY robotic arms that anyone can create. Most commercial robots cost around 20,000 euros. The PAROL6's goal was to bring industrial performance, look and feel to affordable and DIY format, with the BOM being around 1,000 euros. Because of that, it has been built by hundreds of people worldwide, including universities, companies, makers and individuals that just want to learn about robotics. With the growth of the project, PAROL6 found more and more use cases, being used for various tasks like executing G-code commands, gluing, classical applications like pick and place and object manipulation. Its popularity in academia has led to extensive use in simulators, leveraging our open source code, URDF files and mechanical designs. We've seen MATLAB simulators, ROS2 use cases and Unity-based simulators being developed. The project also embraces trends like virtual twins, imitation learning and AI integration. In addition, we're doing a lot of experimentation in teleoperation applications, allowing human operators to control the robot arm remotely. This feature is also particularly useful because of the recent advancements in AI that we can train the robots, and also for the use cases that leverage high-speed, low-latency 5G networks to enable real-time control over long distances. We began exploring the robot's potential for video and product shots, where the camera can be robot's end effector and be used to produce linear, circular or tracking product shots. Our original idea was to use PAROL6 for placing through-hole components on PCBs and automating that task. We're also tinkering with the idea of using a robot to place PCBs in testing jigs and after the flashing and testing is complete, remove them. PAROL6 supports 3 different grippers: a compliant electric gripper, vacuum grippers and pneumatic grippers. Our SSG48 electric gripper is an open source plug-and-play option for PAROL6. It can control its position, speed and torque. It can also detect objects and measure their size. All of that is making it one of the most versatile grippers on the market. Thanks to its compact size, optimal motor placement, high precision gearboxes and efficient software, PAROL6 can achieve extremely high speeds. Some of the specifications of PAROL6 are as follows: payload of 0.5 kg, repeatability of 0.05 mm, reach of 400 mm, and it weighs only 6 kg. All the STL files needed to build the robot are open source and you can print them on any FDM printer with only 2 kg of filament. All the other parts can be bought off the shelf from sites like Amazon and AliExpress, with the total BOM being less than 1,000 euros. The robot assembly is divided in logical sections and you can build the robot by following either the PDF manual or following our video instructions on how to build the robot. All the software for the robot is open source. The GUI you see here allows you to jog the robot in joint or Cartesian space, to record and replay programs, to control grippers and outputs of the robot, error logging and much more. It allows you to program your robot in just a few clicks, and in the rest of this video we will show you how easy it is to use PAROL6 robot. So the first thing we will see once we open the PAROL6 Commander software is that it will open two windows. The first window will be used to program the robot and perform jogging and see all the stats about it, and the second window will be the simulator window. The first thing we need to do once we open Commander software is to home the robot, and that is what the robot was doing until now. The first thing we will do is jog the robot in the joint space. When pressing the arrows, individual joints will move. We can also adjust the speed by moving the sliders. In the bottom right corner you can see a response log. It will show you what commands are being used, errors and more. Now let's go to Cartesian jogging. This will allow you to move the robot in X, Y and Z directions either in tool reference frame or the world reference frame. In this example we are moving the robot in the tool reference frame. That is the frame that is attached to the end of our robot. Now let's switch to the world reference frame, and this is the frame at the base of our robot. During any move, you can stop your robot by pressing an E-stop. After that, the robot will be disabled and you need to press an enable button and enable your E-stop. Now we are in the I/O tab of Commander software. This will allow you to control inputs and outputs of PAROL6 Robotic Arm. As you can see here, one of the outputs is connected to the pneumatic gripper and we can open and close it. Now that we know how to jog the robot and how to control the gripper, we can program the robot to do some simple pick and place tasks. You can program the robot by pressing commands on the right side and they will show up in the program window, or you can manually write commands. In this example we will use the drop-down menu on the right side to program the robot. Every program needs to begin with a begin statement and end with an end or loop statement. Our first code will be to open and close the gripper. To do that we will need to use two simple commands, output and delay. Now once we wrote our code we can press start button and it will execute our simple code. Now let's try to program our robot to do some tasks. First, let's go to the Move tab in Joint Jog. Let's move the robot to some random position. And now on the right side let's select Joint Space commands and select Move Joint. What that command will do is move our robot to the current position that we recorded. We can also select how long the move needs to last. For example, in this case let's enter 3 seconds. But for the robot to move to that position it needs to be in some other position, so let's move it a bit. And let's press start. And as you can see the robot moved to that position in 3 seconds. Okay, let's try to move robot to another position and record it. Now what we will want to do here is record this position and then set gripper to close, and before that we will need to open it. Let's also change end to loop, and you will see that our robot will perform these actions indefinitely. Hopefully this short guide on programming was useful, and if you want to learn more you can check out our documentation, and you will find more info about the robot on how to build it and use it in the links in the description.